Alright, it is time to learn about the eye rigging. Now please note before we get into this that I will be showing how to make the full rig, but I'm not going to be explaining the details of every rigging constraint and concept. So if you don't already have some familiarity with bone constraints, go watch some other videos on that first. Let's get an overview of how our rig is going to work by looking at the setup in the original file. We've got two main layers. First, the control layers. This is what you actually interact with to work with the eye. And then underneath the hood, this is we can't really call it deform bone layers because this isn't working with an armature modifier, but this is the bones that actually move objects and have relationships to each other. And then on my third layer is just a couple bones that are hidden and not actually used, but exist for reasons of mirroring. So we'll talk about that later. So what exactly moves what? On our control bone layer, we have all sorts of controls for adjusting the scales and even rotations of different parts of the eye, but I'm actually going to turn those off, and we're going to look at the lower level first. Let's take note when looking at this that I use several different custom shapes for my bones. I've got a bunch of them here. And some of those are just to make it so that you can tell what controls what, and they've got different shapes so you can tell at a glance which way they're rotated. But on these ones, this is simply because if we look in edit mode, a lot of these bones are in the same location and they overlap each other. So if they don't have different shapes, they can be difficult to select. Here, selecting the one on the inside can be difficult. So I use several different custom shapes in order to just make it easier to select any given bone. Each side of the rig is made up of a main eye bone that can move the entire side of the eye, the pupil and iris bones that the empty objects are actually attached to, a tracker bone, the tracker target, which is controlled by the control bones, and a bone that tracks to that target. There's also a root bone that controls everything and can be used to adjust the position and rotation of the rig. Part of the idea of the rig is this isn't just controls for adjusting the expression and the eyes themselves. Many of these are also for positioning the eye to fit your character in the first place. So these eye bones can be moved side to side and rotate on Z and also moved on Y, so you can fit them to your character's head. And then you can move either the root bone or the whole thing in object mode, and the whole setup stays together because of the way we've set up the parenting. So it should be easy to position on your character, adjust a few bones, and then apply that as your rest pose, and you're good to go. Let's also note the position of these bones that control the eye. They're all the way back here behind the eye. Why is that? Well, if you remember our reference sphere, these bones are actually in the center of where that sphere is. These bones represent the center of the eye if it was spherical. That makes it so that when we do rotations, the objects that project the texture stay properly on the curved surface of the eye. It's worth noting that you could make a setup like this for eyes that aren't ultimately a large sphere, if you wanted them to be totally flat, or if they had different amounts of curvature in different areas, like maybe if you were rigging very stylized eyes or monster eyes or whatever. You can still make rigging setups, but this one is ultimately based on rotation. So if you needed it to move differently, you would need a more advanced rig, but that is possible. Another feature of this rig is that the eye tracking actually has some offset. This is the tracker bone, which points at this target, and this target is of course controlled by the control bones. And if we move that, we can see this is pointing exactly at the root of this bone, but the eye itself isn't. And that's because the iris and pupil bones are actually controlled by this offset bone. And this offset bone copies the rotation of the tracker bone, but it only copies 1/3 of it. And the reason for that is if you want to do something like constrain your eye controller to your camera and have it appear that the character is looking at the camera, if you have 100% of the tracking, due to perspective and other issues, often it won't. The eyes will actually rotate too far. So this offset bone lets us compensate for that. Now that we understand the basic setup, we can go to our new file, lay out these base bones, and then start talking about exactly what constraints each has and what parent-child relationships. I've started with a new armature object with the viewport display set to wire and axes enabled so that we can pay attention to the individual axes of our bones. I also use the eye reference sphere to find the midpoint of where the eye would be if it was a sphere, and that is where I have positioned my bones. And I've brought in my rigging shapes from the other file, so if you want some bone custom shapes and you're following along, now might be the time to make a few. And it's important to note that custom shape objects need to be given some rotation if they're going to line up with these bones. All of these objects have 180-degree rotation, and that's because custom shapes expect the bones to be pointing up on Y, positive Y, but because our eyes point negative Y, and I have all the bones rotated by 180, the custom shape needs to be rotated by 180. I also, of course, have mirroring enabled in object mode so that anything I do to one side happens to the other, although we don't always need that, and of course that only works on bones that are named ending in .r and .l. So these will be the two eye bones, and the next step is to duplicate this one and go get ourselves a root bone, and since I have mirroring on, I have an extra, so I'll disable mirroring, delete that, and rename this to root so that it no longer has any mirroring and put mirror back on. Actually, I think I could have just renamed it without disabling mirroring and set that to 0. So there is our root bone. And I'm going to scale it up a bit just so I can keep it separate. And that's on individual origins. And while we're here, let's go ahead and hit M and move everything to layer 2 right away. And then take both of these and parent them to the root bone with Control P, keep offset. Then we'll tab out to pose mode and assign these with a custom shape right away. Find my display, custom object. They'll get the square. And there we go for our base eye bones. Next up is iris and pupil. Duplicate the bone, we'll move it forward on Y. I'm going to need the exact location of these. So let's snap our cursor there. Go ahead and remove the square from these. And we'll rename this to iris. And then in edit mode, we can snap it to the cursor. Duplicate that, scale it down. That will be the pupil bones. And we'll give them a custom shape. I'll leave the iris as the base, that's fine. And duplicate the iris bone again and bring that forward a bunch. Exactly how far doesn't really matter. And these will be the targets. They don't need any custom shape. Let's go into top view just to make sure that we kept everything lined up. When I was moving these bones, I have been locking them to the Y-axis, so that's all good. And we can stick our 3D cursor back on that bone. Grab our iris bone, duplicate that again. These will be the tracker bones. And I'll scale them down a bit and snap them to the cursor. These still don't need a custom shape. Then we'll duplicate those again, scale them down again, and this will be the track offset bones. And since these are all overlapping, I will want to give these a custom shape. And that one again. I don't have these selection problems. Now there's actually all of the base bones laid out at this point. So next, we need to make sure they have the right parent and child hierarchies. The eye bones are the child of the root bone, and they copy all the rotation, so those are fine. Check that. And actually, we'll turn off axis view at this point. Then the eye track bones are also the child of root with full inheritance. The eye offset bones are the children of the eye track bones. So let's, right now the child of root, let's select that, and in edit mode, make parent with keep offset. And now eye track, and that did not mirror, so I'll have to do it on this side too. And just grab those to make sure that's working. All right. And the iris and pupil bones need to be children of the offset bone. And I like to do my bone selecting in pose mode because it's easier, because you don't have to worry about misselecting the head and the tail, and you have the custom shapes. So I'm just tapping in that a lot. And these target bones can stay the child of root for now. We'll actually be inserting another bone later. Now that we have the basic relationships down, we can get into the constraints. This eye tracker should move with the eye bone, but not rotate with it. So that's why we haven't parented to it directly. Instead, we'll use a copy location constraint. And since we always wanted to just copy the location of this bone, we can leave that on world space. We don't have to worry about world space versus local space for bones that are sitting on top of each other. Next, we want it to always point at this bone. So for that, we will use a damp track. And the y-axis is fine. And now we can see that as we move this, it's going to point at it. And lastly, these get a copy rotation constraint, or a limit rotation constraint. So I'm going to put that there to remind us to use it later, but we won't set it up just yet. Next is the eye track offset bone, which is what actually controls the iris and pupil bones. This bone needs to rotate with the eye bone and also rotate when the tracker bone rotates. Currently, it's doing that through the parent-child relationship, but the purpose of this bone is for it to only get a small proportion of the eye track's rotation, well, a controllable amount. So if we use the inherent rotation, it'll always get 100%. So instead, we're going to give it a pair of copy rotation constraints. We'll put the first one targeting the main eye bone, and we're going to use local space. And after original, if we have it on replace, then it overrides any rotation we add. If we put it after original, it adds it afterwards. So we can still play with this by hand. That's not really necessary for the whole setup, but it's nice to be able to check what's going on and not have the constraints lock everything down. So now it rotates with this bone, but if we go ahead and rotate the root, we see that there's actually a problem, which is now it's not rotating anymore. And that's because we did local space to local space, where actually what we need is local with parent. So what local space means is that it will get the rotation from the bone it's copying, but if this bone is getting rotation from a parent, it won't get that. And that's a very important distinction that'll come up a lot here. So make sure we have that on local with parent. Now we'll add a second copy rotation, and this time it will be to the tracker bone. And this can also be after original. And this time it can just be local to local, because this we don't want it getting rotation from this bone's parents. Otherwise, we'll get the rotation from the root bone twice. So now as we move this, it copies the tracker bone, and then we can also have additional rotation from this bone. And this is where I'm going to turn the influence down to only 1/3, 0.333. And depending on your character, you may need a different number. That's just the number I've been using so far. Another feature we want is for our target bone to also move with our eye bone, because we want to be sure that wherever we move this to, if we move it to the side, that's now messing up the tracking. So we want the target to always be in line with the eye bone on the x-axis. So that's also going to be a copy location, set to eye, and that will need to be local space. It doesn't need to be with parent. And I'm going to enable offset just so we can still move it, because otherwise it's locked. And we don't need y-axis because we don't actually want the target changing location if we adjust this. The last bone we'll add for now is the one that I didn't talk about before, which is this one, which I've called eye tracker follow. So one of the features it's nice to have on a rig is to be able to have the eye tracker follow the root bone. So this root bone will eventually be parented to the character's head. And that will mean if you rotate the head to look in a certain direction, it's going to adjust where the eye controls are. But what if you want to keep these in one place and not be influenced by the head's movement? Then you need a slightly different setup. You need a bone that follows the location of the root bone, but not necessarily copies its rotation. So now if I rotate this, it's not affecting where the controls are, and the eyes will keep trying to look towards the controls. So that's what this intermediary bone is for. So to make that, we will duplicate the root bone, scale it down a bit. Let's immediately give that a custom shape. And this bone is not a child of the root bone. It will be parented to whatever head bone the root bone for these eyes gets parented to, but it will follow the root bone with a copy location and also a copy rotation. World space is fine here. We don't need any extra settings. I'll rename it. Called the eye tracker follow because it's the bone that the eye tracker follows. I think I could come up with a better name, but it doesn't really matter. And the reason we use these two constraints is so that they can be disabled or the influence adjusted, because usually that feature I was talking about is something you would have a driver to control. At the end of this, I'll be showing how to merge this into a Rigify rig, so we'll cover setting that up then. And we want the two eye target bones to be children of that follow bone, as will other parts of the controls when we get to that. Now, the base layer of our rig is pretty much done up to this point, but of course the empty objects that actually project our eye textures aren't moving with the bones yet, so we need to get those attached. And for that, we will constrain these empties to the appropriate bones using the copy transforms constraint. We'll go ahead and set that there to the iris. And now it's copying the iris in world space, which means it will stay glued to it no matter where it goes. And again, that's fine to use because they're occupying the same location anyway. But there is one problem. We just haven't seen it yet. I'm going to enable axis. And when we turn on this constraint, we see, if we zoom out, that it's actually flipping the axes. It doesn't show it here in the rotation, but it's actually rotating the object by 180 degrees. And the reason for that is because base, this empty is pointing down the y-axis that way. But if we remember our bone axes, the bones are actually pointing this way. So when we copy it in world space, copy transforms exactly matches it. Now we could replace this with like a copy rotation and a copy location and a copy scale. But in this case, we can use copy transform still because this rotation doesn't actually matter. Now, the reason it doesn't actually matter is because for object coordinates, it's projecting the same texture in either direction. So if you flip this, it won't actually matter, well, except it does. And what's mattering at the moment is, you may remember that that inner circle is mixing the iris and the pupil coordinates, and we've just flipped the iris coordinates by 180 degrees, but we haven't yet flipped the pupil coordinates. So let's go ahead and on the pupil object, we're going to add the same constraint. Got it. Get on the rig. And now they are both being flipped by 180 degrees, so the problem is gone. But yeah, the copy constraints, the copy transforms constraint is pretty annoying in the way it behaves. And unlike the other various copying constraints, you can't exempt certain axes or anything. So you always have to watch out when using it. Now let's give it a quick test and make sure things are behaving properly. If I move that, that's moving correctly. And if I scale or rotate these, that's doing things. Again, we can get some weird behavior from mixing the pupil and iris vectors in the material. So you can disable that if it's causing problems. But it's only really an issue if you scale the pupil and then rotate it separately, rotate things in different directions. It gets pretty weird. But that's probably not something that most people are ever going to do. So you can decide if you want to keep that or not. So that's all working pretty nicely. And that will be all we cover in this video. In the next video, we will of course be talking about setting up the rest of the rig controls so that we can have much finer control over all the details of the eye. Thanks as always for watching, and remember that you can already get this base file if you follow me on Patreon before the end of March 2021, or you can get it on Gumroad. So please pick that up if you want to support me in making more videos like this. Thanks.